All right, we are moving into section 1.5 on our quadratic equations. This time we are going to be looking at equations that not only have just a power of 1, but also a power of 2. So when we were looking in section P.5 with factoring, those were considered our quadratic equations. And so we're going to learn how to solve those with 3 different methods. First, we're going to do by factoring, actually 4 different methods, then our square root property, and completing this square. We're going to save the quadratic formula for the next class. So we're kind of splitting this one into 2 parts. So this is part 1. So a quadratic equation in X is an equation that can be written of the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and that first value is not equal to 0. Now, when we talk about the degree, don't forget the degree of a quadratic equation, that's the highest power on our variable. For all quadratics, it will be a 2. So, here are some steps in order to solve things by factoring. In P.5, we practice that factoring. That is so important to make sure that you remember how to do that because we will use it over and over and over. So number 1, we want to get the equation equal to 0. If it's not, make sure that you get it there by moving things side to side. Then we are going to factor that polynomial completely. And then we are going to set each factor equal to 0 to solve for the variable. So now, instead of just factoring it, now it says to solve by factoring. So that means now we actually need to find the x value that makes that true. So if I look at this first guy, when factoring, don't forget that the first rule of factoring is to take out any common terms. So there's 2 terms here. Each of them have a 3, and each of them have an x. So I'm going to take out a 3 and an x, and figure out what's left over. So 3x times what gives me 3x squared? Well, I have an x left over minus 3x times what gives me a 9x. Well, I took 3 away from the 9, so I need 3 left over as well. So this is actually completely factored. And so if this was kind of gone away from here and we just said factor, that would be your answer. But now that we say solve, you have to go one step further and say, okay, if the product of these things is going to equal 0, then that means that either this equals 0 or this equals 0 or both. So we wouldn't want those possibilities. So I'm going to kind of separate it here. I'm going to take this first term and set it equal to 0. Take my second term and set it equal to 0. And now I have 2 equations that I can solve. So, dividing by 3 each time gives me x equals 0. Remember, 0 divided by anything is 0. And when I add 3 to both sides, therefore, x equals 3. So, therefore, x can equal 0 or x can equal 3. And so, by my solution set notation, you might see it be written like this as well. Okay? So, hopefully you'll get away from doing this because a lot of times this is a lot more work. So if you can ask yourself what number times 3 is 0, you get 0. What number minus 3 gives me 0? It is 3. And so hopefully eventually you can kind of get away from solving those equations. But if you need to do that, by all means, go ahead and do so. All right, let's factor this equation. It is equal to 0, so that's good. It is a trinomial this time. So if you recall when factoring, we have 2 binomials that it would break down into. The last sign is a plus, so they are the same that match the first. So we have a minus and a minus. I'm going to split up my x squared as an x and an x. And now since I have a nice 1 in front, this is where we get to use the trick. What do we multiply to get 12 that we add to get 8? Well, 1 times 12, 2 times 6, this gives me 13. When I add, that gives me 8. Oh, ding, 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 I don't need to go further. Therefore, I'm going to throw 2 and 6 in as my factors, x minus 2, x minus 6. And now, again, you can, if you want, set each one of these equal to 0. But I think it's easier just to say what number minus 2 is 0? That's 2. What number minus 6 is 0? And that is 6. So 2 and 6 are our final answers. All right. Next one. Notice we don't have 0 on one side, so we've got to get it there. I'm going to bring that 1 over and give us 2x squared plus x minus 1 equals 0. Just like last time, we have a trinomial that we can factor. But this time we have a number in front, so it's not as easy as what we had over there. So I'm going to go ahead and do my signs. Last sign is a minus, so they are different inside. I'm going to split up 2x squared, so the only factors of 2 are 2 and 1, so one has to be a 2x and the other one has to be just a 1x. And then the only factors of 1 are 1 and 1. The only question would be, do I have the right sign? So if I check my outside and my inside, this is a negative 2x and this is a positive 1, so I do not have the right sign. So let's get our eraser in here. Get rid of that. And so I'm going to end up having, let's see, this needs to be a minus 1 now, and this needs to be a plus 1 now. Okay? And so I can now set each one of these equal to 0. Now this one, hopefully you can tell me what number plus 1 is 0. Well, it has to be a negative 1, okay? And again, if you want to set that equal to 0 and solve by subtracting 1, that's where you get your negative 1. This one with the number in front is a little bit different. If I were to solve that, I need to add 1, so I get 2x equals 1, and then when I divide by 2, then I get x to equal 1/2. So that gives me actually my other number, or my other solution for that. So here's how we do it in a shortcut sense. Anytime you have a number in front, and it actually works for this one too, but you will be taking the opposite of this over that. So the opposite of the constant over the number in front. So if I have like 3x minus 2, the opposite of what I'm looking at is a positive 2 over 3. 2/3 would be what I kick out on that. Okay? All right, so you'll see that over and over again, and you can always come back to solving that equation if you need be. All right, let's try this guy. This one definitely is not equal to 0. This has a quantity squared that if you need to write that out twice and FOIL it, then you need to do so. So let's do that first. We need to FOIL it. So I'm rewriting the left. I need to do my first term. 2x times 2x is a 4x squared. Outside, 2x times 1 is a plus 2x. Inside is another plus 2x, and the last one is a plus 1. Now, if you know the pattern of that with that 2x plus 1 quantity squared, where you square the first, multiply the 2 and double, and square the last, then you can use that too. It makes it a lot easier time-wise. But if you need to write it out twice and FOIL it, please do so. So I'm going to combine these two middle terms to give me a 4x inside here, equal to 1. Now, we're not even equal to 0 yet, so we have to still keep working. So I'm going to bring this 10x over and this plus 1 over. So I get a 4x squared. Now, for the 10x, I have to subtract it. So 4x minus 10x is a minus 6x. And adding the 1 over gives me a plus 2 equals 0. Now, we actually have a little advantage that we have here that we could do. Notice that each one of these has a common 2, so I could actually divide all of my terms by 2 if I so choose. Okay, as long as it's a common number, you can do that. And it just reduces things down. So I'm going to kind of extend my page out and write it down here. This becomes a 2x squared minus a 3x plus 1 equals 0. Divided by 2 is 0. And so this just reduces your numbers and makes your factoring a lot easier. So here we go. This looks very similar to the last one with a 1. The only factors are 1 and 1. The only way I can split up 2x squared is 2x and x. And this time I have the same signs that match the first, so that means each one of these have to be a negative. And so if you were to check your outside and inside, you do get that negative 3x. So here's one of those with the number out front. Let's do the opposite of what our eyes are looking at. So make that a positive 1 over this 2. Gives me a 1/2. And what number minus 1 is 0? It is a positive 1. Now, you can do that same trick, opposite of what you're looking at over the number in front, which is 1. Still gives you a 1. So either way works, okay? All right, very good. So that is solving by factoring. Knowing how to factor is so important. So if you're having trouble, please come see me. Another way to solve a quadratic equation is by the square root property. And it is not too bad. Okay, the square root property is going to get us to where we isolate an x squared term by itself, and then we're going to square root both sides in order to make that true. So if you flip over or go to the next page, the idea of this is to isolate the quadratic term, or I'm just going to put the x squared term, and then square root both sides on the equation to solve. Now when I do that, there's going to be two answers that work, and so I'm going to put here, don't forget the plus or minus on the number side. So what do I mean by that? Well, that means that if I have x squared equals 9, let's say, then there's two numbers that work there. I could put 3 in there and square it to get 9, and I could put negative 3 in there and square it and get 9. So what's going to happen is we're going to square root both sides, and on this number side, we're going to throw in a plus or minus. So therefore, the square root of x squared, well, what do I square to get an x squared? It is an x. And then the square root of 9 is a 3, but I have two possibilities, the plus root or the negative root of that. So that's kind of where we're leading to. But you may not have the x squared by itself to start with, so we have to get rid of this 21 to give us a 3x squared equals 21. But then I need to get x squared by itself, so I'm going to divide both sides by 3, and therefore x squared is equal to 7. Now, to undo a square, we're going to square root both sides. Again, on this number side, make sure you do a plus or minus. This determines, just gives me an x, and I can't reduce that 7 like I could the 9 above, so plus or minus root 7 would be my answer. Okay? Now, let's see if we could get this by itself. Well, we're going to add over that 45. And then I get 5x squared equals 45. I'm going to divide by the number next to that x squared term. So I get x squared is equal to 9. So I kind of got what I just had up there. Square root both sides, plus or minus on the right side, therefore x equals plus or minus 3, and that would be my final answer. Now, I'm going to interject here, and we kind of skipped over 1, 4 in our sequence, so I want to make certain that you know that if you ended up having something like this, where this is a plus, I'm going to modify this, and this, then I would have to subtract, which would leave a minus, which would leave a minus here. There's something that for imaginary numbers, whenever we take the square root, and when we do 1, 4, you're not gonna know how to do this, but for this time being, if you get a problem in your assignment that has a negative underneath it, it can be done. So the square root of negative 1 is equal to I. So when I do the square root of negative 9, it would end up being an answer of plus or minus 3i. So you kind of have to just attach that imaginary number to it. So again, that would be much more clear whenever we get through section 1-4, but as of right now, that might be a little bit on the strange side. All right, so let's try this last one. This last one is a little bit different because we don't have just an x or a variable that's squared. What I have squared this time is an expression. So this is leading us to what we're getting into with completing the square. That if I have that number squared, I want to get in here to solve the x. So I need to go ahead and square root both sides. Again, don't forget this plus or minus over here. And the idea, if I square root x squared, I just get an x. Well, if I square root this quantity squared, what I'm going to be left with is just that 2x plus 3. In a sense, that square and square root cancel each other out. Equals, over here, it's nice, I do get a whole number, because 25 is a perfect square. We're left with plus or minus 5. All right, let's solve for x. If we need to solve, we need to get x by itself. So I'm going to keep going and subtract 3. Now, that looks kind of funky with that plus or minus. I'm going to write this as negative 3 plus or minus 5. Then I'm going to divide by 2 and divide by 2. Now, because this is a perfect square, we can actually figure out what numbers those are. If it is like 7 under there, or you know, something that doesn't break down, then your final answer, if that was 7, we could have negative 3 plus or minus square root of 7 all over 2, okay? And that would be your final answer. But here, this is telling me I need to do negative 3 plus 5 all over 2, and negative 3 minus 5 all over 2. So it's kind of a simplified way to write two different things. And so if I do the math on this, negative 3 plus 5 is 2, all over 2 is 1, and negative 3 minus 5 is a negative 8, divided by 2 is a negative 4. Therefore, these would be my answers for that problem. Okay? All right, again, that's leading us to do what we're getting ready to do, which is completing the square. There are two ways to solve a quadratic formula that cannot be factored. So not every single equation that we encounter is one that can be factored. So we're going to look at the first way to do that, which is called completing the square. It's a method used to convert an equation into a quantity squared equation, just like what we had right here. That's a quantity squared equation. So we're going to force things to be like that, and then we can solve it by square rooting both sides. So here are the steps in order to do completing the square. And this is actually used with circles, parabolas later on. So this process you really want to make sure that you hone in on and get. So if a is not equal to 1, a meaning that first x squared term, then we're going to divide each term by a. We have to have a 1 in front of that x squared in order to complete the square. Then we're going to move the c, this c, which is the constant, to a side by itself, leaving the variable terms on the other side. Now, the next step, step 3, is the most important. We want to take half of the linear term, which is the x term, that's that b, half of the linear term, you can put a b there if you want, and add the square of that number to both sides. I know there's quite a few steps here, but just write these down and we'll go step by step. Now, factor the left as a quantity squared, then simplify the right side, and then we're going to get back to what we just did on that last example, square root both sides. Do not forget that plus or minus with the number, and then we'll solve for x. So we've already kind of done half of it. We did 4, 5, 6 a little bit, or maybe 5 and 6, but now we're going to kind of just work with the whole process. So the most difficult part, I said, was step number 3. So they, in your book, give you kind of a nice little exercise for you to determine what is that constant that we have to add to both sides. So what I like to do is I like to prep when we do that, and I do a quantity squared. And I want to take, in order to get that new number, we have to take half of the linear term. So half of the x term. Now don't look at the x, just look at the number. Half of 6 is a 3. So when I do that, that's what's going to be added to both sides. But for this exercise, they're just wanting you to do the completing the square part. Now, what happens when you get this? This is technically x squared plus 6x plus 9. If we were to factor that with two binomials, you will find that it will be exactly the same. So we can write it as a quantity squared. Now here's kind of the trick. If you don't square this out, it's going to be very easy. Take one of these in the front, make that an x. Take one of these in the back, and the first sign matches, and that's your quantity squared every single time. Again, one in the front, take one of these, first sign matches inside there, and you now have your quantity squared that we need to use in order to complete this square. Okay, so what do we have to add here? Well, we have to add something squared. This is going to be what we need to take half of, which gives me a 4. And now I can create my quantity squared. Take one of these, take one of these. First sign matches inside, and that is going to lead us to our completely solving down. Okay? Now, this guy here is not a nice even number that I can take half of, but that's okay. Okay, so I'm going to prep for this. If I take half of 5, you get 2.5, but we're not going to the decimals. We're not even going to mixed numbers. We're going to rewrite those as improper fractions. So just write it as 5 over 2. Now again, That creates a quantity squared that I can factor. Take 1 in the front, take 1 in the back, and then the first sign matches. And that's going to help us out on the left side when we start doing these equations by completing the square. Okay? Alright, so as I scroll up, we can't see our steps, but you can see them on your paper. First thing we need to check is A equal to 1. Is there a 1 out front? Yes, we're good. So we don't have to do number 1. I do have to then, for number 2, move that C to the other side. So I get x squared plus 4x, and I'm going to bring over here and leave it a little space. Okay? So make a little space there so that you can get ready to do our prepping like what we were doing up here, okay? So this is where I want you to include number 3, okay? We're going to add the square of a number to both sides. So this is kind of like 2 and 3 in one step. I need to take half of the linear term, which is 2, and add the square of that to both sides. So I like to just do it this way, by adding here and adding here. That's the same to keep it balanced. And again, this now becomes that quantity squared. So we're now down into step 4. Take 1 in front, 1 in back. First sign matches with a plus. And I'm going to simplify the right side by squaring first to get a 4 plus 1, which is a 5. And now we're right back to where we had that third example on this page, where if I have a quantity squared and I want to get into the x, I'm going to square root both sides. Do not forget that plus or minus on that right side. This square cancels that square root, leaves me with an x plus 2 equals your plus or minus root 5. And then I just now need to get x by itself. So I have a plus 2 here. The opposite is to subtract 2. And we like to normally do our plus or minuses at the end. So therefore I'm going to write this answer as negative 2 plus or minus root 5. And that is the solution or solutions to our equations that we just saw. Okay? Alright, very good. Let's try another one. The next one, we have an A equal to 1. Very good, we can skip step 1. Notice that our constant is over here by itself. So in a sense, we can skip step 2. But I'm going to go ahead and kind of prep again. Get ready for step 3. By adding the square of a number. And so that number has to be half of the linear term. Again, we have a 4, so half of 4 is 2, and 2. I'm going to create that quantity squared on the left side. I'm going to clean up the right side in this same step. So take 1 in front, take 1 in back. First sign matches. And then 12 plus 2 squared is 4, so 12 plus 4 is 16. And now I need to get in to solve for x. So in order to do that, we must undo this square. So let's go plus or minus on this side. This square cancels that square root, leaves me with an x minus 2. And this just so happens to be a nice perfect square, which is 4. And when I solve for x, I'm going to add 2 to both sides. This goes away. So x equals 2 plus or minus 4. But again, since that's a perfect square, we can figure out what they are exactly. So what is 2 plus 4? That's a 6. What's 2 minus 4? It's a negative 2. And that would be our final answer. Okay? All right, 2 more. We've got this. Let's figure out what we need to do to complete the square right here with this guy. So I'm going to start by looking to see if A is equal to 1. Notice this is our first time when A is not equal to 1. So we're going to divide every single term by 2. Now, when I do that, this goes away and leaves me with an x squared minus a 2x. Now, I'm going to kind of save ourselves some steps here. In step 2, we got to move this guy to the other side. Now this, remember, is 0. So I'm going to move that 1/2 over by adding 1/2 to both sides. And I'm going to, at the same time, prep to make sure that I can get my completed squared part. So when I do that, I'm going to take half of this middle term, which is a 1, that I need to add to both sides. Again, the left side becomes the quantity squared. 1 in front, take 1 from behind, same sign as the first. And then 1 squared is 1 plus 1/2 as an improper fraction is 3/2. Use your calculator if you need to. This again is going to be 2 over 2 if I change that to a common denominator. Alright, let's square root both sides. Do not forget your plus or minus on this side. What I'm left with here is an x minus 1. And right here, when we go back to our rational, our square roots, which I believe was p dot 3, this is where we have to, if you remember, square root of 3 over square root of 2. Let's go ahead and times by that radical that's in the bottom. And so what I get is plus or minus, this gives me root 6. And root 2 times root 2 is 2. So make sure you keep with everything that we've learned so far in simplifying things. To get x by itself, let's add 1 to both sides. Therefore, x equals 1 plus or minus root 6 all over 2. And that would be my final answer for that problem. Okay? All right, and the last one I'm going to stretch it a little bit also with some fractions. So make sure that you are able to do fractions or have them checked on your calculator, either one. Notice a is not equal to 1, so I'm going to divide by 3. Do not forget to divide that 2 by 3 as well. So this becomes x squared plus a 3x. Now notice my constant's already on this side by itself, so I'm just going to kind of rewrite it out here. And I'm going to prep for my square that I have to add to both sides. Alright, now unfortunately this is the only one that this is not an even number. So when I take half of 3, I'm only going to write it as 3/2 and 3/2. So this again gives me that quantity squared. 1 in front, 1 in back, and the same as the first sign goes in between. And here's where little fraction work comes into play. So what you need to do is to make sure that you add 2/3 plus 9/4. So you'd have to get a common denominator there if you wanted to. I will tell you that when you do, you end up getting a 35/12 when you do that. Okay? So, solving for x, again, you got to make sure you keep up on what we've done before. Don't forget your plus or minus on the right side. Square cancels the square root, leaves me with x plus 3/2. Now, let's do a little work on this guy. This is the square root of 35 all over the square root of 12. Now, I'm thinking that 12 can be split as 4 times 3. Square root that 4 gives me a 2 square roots of 3. And so this, when I rationalize, just like what we just did with this up here, I'm going to multiply top and bottom by root 3. So what I end up getting on this side is plus or minus 3 times 35 is 105 over root 3 times root 3 is 3 times this 2 out front gives me a 6. So make sure that you have that there. Okay? Final answer. I'm going to subtract 3/2 from both sides. Whoops, that should be a 3. And my final answer for x is going to be negative 3/2 plus or minus root 105 all over 6. And that is our final answer. So they're not really pretty all the time. Sometimes it does take a little bit to kind of get down, but make sure that you go step by step and then follow each one of these steps to get your answer with completing this square. Okay? So in the next section, we're going to add on our last way, or our next cast, we'll add on our last way to solve quadratics, which is by quadratic formula, which a lot of people like in that sense. So until next time.